Okay, so we started off yesterday with the concept of the fundamental theorem of algebra, right? And this is something you should always have in the back of your mind, in the fact that it says that there are as many complex number roots as the degree of the polynomial. So if you read the degree of the polynomial, you'll figure out the total possible number of roots. But not only does it correspond to the roots, it corresponds to zeros. There are up to that many zeros as the degree. And as well, there are up to that many real and complex number solutions up to that degree. And so that's something that should always be in the back of your mind. It should always then help you to figure out, hey, how many solutions am I expecting in this situation? We started then also talking about the conjugate root theorems. Hopefully the conjugate's a little more clear in our minds now. If you multiply conjugates together, taken together, they're a difference of two squares. So basically, they're binomials. The middle sign of one is positive, the middle sign of the other is negative, right? I mean, you look at the example here, and those are conjugates. A plus the square root of b and a minus square root of b are conjugates. And what the theorem says is, if you have a root that involves a square root, it's an irrational root, then you're going to have its conjugate. And also, if you have a root and it's a complex number root, involves an imaginary number, you're going to have its conjugate. So by knowing you have one irrational root, you know you got its conjugate, you got a second. By having one complex number root, you know you have its conjugate. Okay, that then led us to the concept of trying to find all the zeros. And so we had an example here. We're trying to find all the zeros, and they gave us help. They told us that x plus the square root of 2 was a factor already. Because we knew it was a factor, we knew its conjugate was a factor. Multiplied out the conjugates to get the x squared minus 2. Use that in long division to figure out any other factors, and we got that one. So the reality was it was the 2x minus 1 factor, and then the two irrational roots. If they were asking for the roots, then if they were asking for the factors, that would be the answer in factored form. If they're asking for the zeros, you'd have to go further, and that's what we did. If this were an equation set equal to 0 and they asked you for the solution would also be the same as the zeros, x equal plus or minus square root of 2 and then 1/2. Any questions on any of that? This is the key of what we're doing as we put it all together. Any questions about any of that? Okay. All right, so then we dealt with another scenario, write a polynomial function of least degree if. So in this situation, they gave us the roots, or they gave us the zeros, and we had to figure out then what the factors must have been from those zeros, and therefore then multiply out all those factors. So if they said 3/5 was a solution, it must have come from an x minus 3/5 binomial. And again, we want the better form. X minus 3/5 is true. I'm sorry. Yeah, 3/5. I'm thinking 5/3 there. X minus 3/5 is true, but it's not the best form. And again, the easiest way is to just move that 5 up. So 5x minus 3 was that first factor. Oh, there we go again. Love it. And then using the negative 5i. So again, x minus, and then the negative 5i, meant that that binomial must have been an x plus 5i. We also knew, therefore, then there was its conjugate, right? We got the other root. Now we have our three factors, and we got to multiply everything out. multiply it all out, and that's where we end up. All right, so that's that type of question. Number 3, we were looking to solve a polynomial equation or find the zeros. Again, if it was an equation, you set it equal to 0 and solve it. If it were a function, you would set it equal to 0 and solve it. They're synonymous. Solving a polynomial equation or solving a function for the zeros is the same thing. All right, so in this one, we had to go full bore. This is the full process of what we learned the last few days. First off, we had to figure out all the possible binomial factors. Then we had to use the remainder theorem to see if we end up with a 0 remainder to find a factor. So we listed the factors. We found a factor by getting a 0 remainder. We then divided that factor into the original. We then took what it equaled, the quotient, and looked to see if we could factor that any further. And we did. And then we set each factor equal to 0 to solve for the x values. Again, if that were an equation, those would be the solutions. If that were a function, those would be the zeros, the place where the function crosses the x-axis. B was simply a factor situation. It's a difference of 2 cubes. We know how to factor that. We could factor it then and figure out the zeros. Only the trick on this one was the trinomial didn't factor and we had to use the quadratic equation. That's where we left off. Any questions on all of that? Anybody? Questions? None. All right, let's go to the next example. Okay, so now you get a question like this. Solve x to the 4th plus 4 equals 5x squared. All right. So if this were you and you were going to solve this, what would you do first? Just think for a second. What would be your first step? You were told to solve this. All right, anybody? First step. Josh? Okay, I would agree with that. So you end up with x to the 4th. You got to add a negative 5x squared to both sides, right? And what do we end up with on the right then, Josh, when you do that? 0, and that's what we wanted, right? We wanted to set it equal to 0. Again, whether you're solving a polynomial equation, which this is, right? Or finding the zeros of a polynomial function, you set it equal to 0. Okay, that's where we're at now. Now, what would be your next move? So I'm going to give you a second to think, and then I'm going to ask you what you're thinking. What would be your next move? What are you going to do next? All right, who's got a thought? What are you going to do next? Luke? I would try to factor it. Okay, so just everybody stay with me for a second. This is key because some of you guys are going to go off and you're going to spend all this time. So let me go back a little bit here. If you try to do this problem this way, or you try to do every problem this way, that's a big, long process, right? Man, first we got to find possible factors. Then we got to find the one that'll give us a 0 remainder. Then we got to do long division. Then we got to factor off the trinomial of long division and finish this thing off. It's a big process. That thing is long and involved. And it's all so we can factor. That's the whole purpose, so we can factor. So why don't we first see if we can factor the thing? So what would be the method of factoring this? What would you call it? It's called trial and error. And you're going to try 2 binomials. All right, see if you can factor that. So hopefully you've got a hint here. When you look at your lead term, so I could do x cubed times x, or x squared times x squared, right? But that squared right there is a tip-off. I'm going to go x squared. And I gave you an easy one here. Positive 4, 1 and 4, 2 and 2. It's either going to be positive, positive, or negative, negative. What's the middle term? Negative. It's got to be negative, negative. So you either got to try -2, -2, or -1, -4, and hopefully you see that -1, -4. Again, you're thinking, what are my outers? A -4x squared. What are my inners? A -1x squared. For a total of what we were looking for in the middle, a -5x squared, right? Okay. Keep going. Remember now, we're solving this thing. What would you do next? What would be the next step? All right, somebody give me a next step. Abigail? So what are we going to try to do from that? Factor. So factor some more. All right? Factor some more. And Abigail told you exactly how to factor. Factor some more. Hopefully we're at the point where these are pretty automatic. Here, I'll do them in 2 different colors. Keep them straight for you guys. Plus in the middle of one, minus the middle of the other, square root of the first, square root of the last. Plus in the middle of one, minus the middle of the other, square root of the first, square root of the last. It's pretty simplistic, right? Difference 2 squares, both of them. Won't always be that nice. Sometimes it will. Sometimes it will. Okay, let me just pause for a second, let some of you catch up. But just stay with me. I want to review a little bit more at one shot without doing a whole big another problem. Let's suppose this second one would have been a x squared plus 4 instead of an x squared minus 4. Is that technically a difference of 2 squares? Yes or no? Technically, no. Because a difference of 2 squares has to have a negative in the middle. But if we really know what we're doing, we could factor this as a difference of 2 squares. If we really know what we're doing. Now, we've done this maybe once or twice. We haven't done it a lot. Does anybody remember how to factor this? Luke? We know it's x and x, right? So it's really the back is what we're worried about. It is 2i. It's 2i. So again, if you were to check this, right? Again, the outers and inners divide out. So x times x is x squared. Outers plus inners equals 0. And you end up with a -4i squared. But remember, every I squared is a -1. Doesn't that give you x squared plus 4? So that's how to factor what seemingly doesn't look like a difference of 2 squares. It's imaginary numbers. All right, so I bring that up because you might run up against that. And if you're going to keep going, then that's what you're going to need to do. Okay, so finish this thing off with all the solutions. So you're going to write x equal, and how are you going to finish it? What are you going to write? What are you going to write? X equals what? And hopefully you're saying plus or minus 1. Right? X equals 1, x equals -1, x equals 2, x equals -2, so plus and minus 2. 4 solutions, right? You're setting each binomial equal to 0 and solving the little binomial, the little equation. X plus 1 equals 0, x equals -1. X minus 1 equals 0, x equals 1. X plus 2 equals 0, x equals -2. X minus 2 equals 0, x equals 2. And you're done. Any questions on all that? Okay, let me give you one other type of problem, and I'll give you the rest of the time to start working on your homework. Let's just get rid of that. Okay, so let's suppose we come across a problem. They say find all zeros for f of x equals blah, blah, blah. And they do give us some help. So do we have to do the full-blown method? No, we have help. We have help. We know that this is a factor. If we know x plus 3i is a factor, what else we know is a factor? X minus 3i. So let's write them out. By the way, do we already know two of the zeros? Yeah, they happen to be complex numbers, unfortunately, and if you were in a complex plane, you could graph them. I don't know if some would say technically they're not zeros, but we'll list them. It's not a big deal. X plus 3i and x minus 3i. So, okay, how would you now from here get to where you find all the zeros? So think for a second. What would you do next? What would you do next? Anybody thought, what would you do next? What are you trying to accomplish to find the zeros? What are you trying to accomplish to solve a polynomial equation? So what's next? Leah?
You multiply two binomials and get that, and then long division.
Okay, so she said you multiply the two binomials. When you get that, you use it in long division. Because you're after what? What are you trying to do to this thing? You're trying to factor it, right? So again, remember, for the zeros or to solve, you're setting it equal to 0. You're trying to factor it. So let's figure out what you get here. You get an x squared. Again, I just want to remind you, the outers plus the inners always equals 0 for a difference of two squares. Because you get a negative 3xi and a positive 3xi. But the back terms here is a negative 9i squared. So x squared minus 9i squared is actually an x squared plus 9. Again, every I squared is a negative 1. Negative 9 times negative 1 is positive 9. Okay, so here's where we're at. X squared plus 9 divided into 2x cubed minus 3x squared plus 18x minus 27. I'm never a big synthetic division guy. Can you do synthetic division with an x squared lead term? I don't know. I don't think so, but again, I never really got big into synthetic division because my philosophy is, why learn an extra thing that I got to remember, and it doesn't solve everything, and I can just solve everything one way. But some people like it. So, all right. Go ahead and go from there and see if you can go all the way to the end of the problem. And you should have ended up with, let me unfreeze here, x equals plus or minus 2i, x equals 3/2. How many got that? Okay, what's up? Oh, it's a 3, not a 2. The eyes. Yes, beware the eyes of March. All right. How many got plus or minus 3i and 3? There we go. All right, beautiful. All right, good. Okay. So, look, biggest point I made today is if you try to do every problem with the full-blown method, you are wasting way too much time. So you have to think, coming into each problem, do I need to do the full-blown method or not? Do they give me something to help me? Or does the thing just flat out factor? If so, you're going to save a lot of time. All right, that's my time. You got your homework.